The arrival of the interstellar object 3I Atlas presented a statistical anomaly. Its path, velocity, and initial luminosity did not align with standard models for interstellar objects. This was not a singular curiosity, but a combination of factors that created a compelling scientific enigma from the moment of detection. Each new piece of data would add another layer to the mystery, prompting a deep and sustained inquiry into the object's fundamental nature. In mid-2025, astronomical surveys detected a faint point of light moving with high velocity through the outer solar system. Initial observations identified it as the third recorded interstellar object. However, continued analysis revealed characteristics that deviated from the expected profile of a typical interstellar body, starting with the profound improbability of its trajectory. A key anomaly appeared to be its velocity. Observations indicated that 3I Atlas was moving at a speed greater than 60 kilometers per second relative to the Sun. This high velocity meant it could not be captured by the Sun's gravity. It appeared to be an unbound object on a one-way transit through the system. While high speeds are characteristic of interstellar objects, the velocity of 3I Atlas placed it in a rare category. Another notable anomaly appeared to be its trajectory. Interstellar objects are expected to approach the solar system from random directions. Yet 3I Atlas approached on a path with a very low inclination. This meant it appeared to be closely aligned with the ecliptic plane, the flat area where the planets orbit. The statistical probability of a random object arriving on such a coplanar path is estimated to be very low. This was followed by an anomaly in its brightness. As 3I Atlas moved from the outer solar system, its luminosity increased at an unusual rate. The glow could not be explained by reflected sunlight alone. At a distance where many comets remained dormant, it began to brighten, at one point reaching a luminosity 5 times greater than predicted. This suggested a form of early, unexpected activity was occurring. This unexpected luminosity, in turn, suggested an object of considerable size. Based on the amount of light it presented, initial estimates placed its diameter in a range of several kilometers. This would make it substantially larger than the 2 previously identified interstellar objects. The appearance of such a large object on such a specific path further reduced the statistical likelihood of its arrival. These factors did not exist in isolation. Their combination presented a difficult scientific puzzle. The detection of 3I Atlas appeared not as a typical astronomical observation, but as the presentation of a profound statistical outlier that defied simple explanation. The questions raised by its arrival set the stage for a period of intense observation, to see if its appearance would provide answers or lead to even deeper questions. That scrutiny of its appearance revealed a key visual anomaly, which was identified as the absence of a conventional tail. For a comet, solar radiation and solar wind push gas and dust away from the nucleus, forming a tail that points directly away from the Sun. Despite its early and intense brightening, deep imaging of 3I Atlas showed no large-scale tail trailing behind it. This lack of a prominent tail was unusual for an object exhibiting so much cometary activity in its coma. This absence was seen as more confusing by the presence of a forward-facing jet. High-resolution images indicated a narrow, concentrated plume of material being ejected from the object. But it was pointing toward the Sun, not away from it. This so-called antitail is a direct contradiction of cometary physics. Natural outgassing should be pushed back by solar pressure, making this forward emission a significant and unexplained mechanical puzzle. The nature of the coma itself also presented questions. While the cloud of gas around 3I Atlas indicated it was an active body, analysis showed the outgassing was not uniform. The emissions appeared to be irregular and were not consistent with a simple model of sublimiting surface ice. This suggested a more complex and perhaps chaotic process was occurring on or within the object. The overall shape of the object inferred from its light curve was also a subject of debate. The data suggested a dense, possibly elongated or symmetrical object. Unlike a typical irregularly shaped cometary nucleus, 3I Atlas appeared to have a more structured form. This perceived regularity, combined with the lack of a tail and the presence of a forward jet, made it difficult to categorize as a simple, natural comet. The object was active, as evidenced by its bright coma, yet it lacked the defining feature of a comet, a trailing tail. The perplexing visual data demanded a new line of inquiry into the object's fundamental composition. A key compositional anomaly appeared to be its ratio of gases. Spectrographs indicated that the Coma of 3I Atlas was rich in carbon dioxide and carbon monoxide. While being surprisingly depleted of water, this appears to be the inverse of typical comets in the solar system. This specific chemical signature implies the object formed in an exceptionally cold region of its home star system. In addition to the carbon gases, the Coma also showed strong emissions of hydrogen cyanide. While this compound is found in comets, its ratio to other carbon chain molecules in 3I Atlas was unusually low. This specific detail was notable because it matched the compositional profile of the previous interstellar comet, 2I Borisov, suggesting a potential shared origin for interstellar comets. The controversial finding came from the analysis of solid materials. Some spectroscopic data contained absorption lines that were difficult to explain with standard cosmic chemistry. These spectral fingerprints suggested the presence of refined metals and rare earth elements, such as nickel and neodymium, in concentrations that were not in balance with their expected cosmic abundance. Such a metallic signature was unusual for a cometary body. Further analysis of these metallic signatures led to even more perplexing questions. The data indicated a high concentration of nickel without a corresponding high concentration of iron. In natural astrophysical processes, these two elements are typically found together. Their separation in 3I Atlas suggested a process of artificial refinement, a finding that was met with skepticism. With its composition proving to be as anomalous as its arrival and appearance, the investigation looked for other clues. The next phase of observation would shift from static analysis to dynamic monitoring, leading to the discovery of a non-random periodic pattern in its emissions. Infrared telescopes recorded a concentrated thermal signature from the object's core that pulsed, swelling and fading in a precise repeating cycle of approximately 4 hours. This thermal rhythm was soon corroborated by radio telescopes. Observatories around the globe detected a faint, narrow-band radio pulse repeating with the same 4-hour period as the thermal heartbeat detected in the infrared. The synchronization of these two independent signals made instrumental error or random coincidence seem unlikely. Further analysis of the radio signal revealed another layer of complexity. The pulse was not static. It appeared to shift slightly in response to changes in the solar wind. This suggested the object was not just emitting a simple, repetitive beacon, but was potentially interacting with its local environment. This adaptive behavior was unusual and added weight to the hypothesis that the signals were the product of a controlled process. The object's behavior changed over time. Later observations revealed a sudden compression in the signal cycle. The interval between pulses shortened from 4 hours to a slightly faster rhythm. This acceleration of the object's internal rhythm was a notable finding. A natural object's processes do not typically speed up on such a precise schedule. This suggested that whatever mechanism was producing the signal was actively adjusting its own rate. The existence of a synchronized, adaptive, and evolving signal posed a formidable question for natural explanations. The consistent regularity of the pulses was seen as evidence that pointed away from chaotic natural phenomena. This discovery set the stage for a pivotal observation. That observation was a sudden, powerful flare of energy from the object. This surge in brightness was observed to be concentrated and directed. Immediately following this flare, orbital tracking data indicated a shift in the object's trajectory. Its path through the solar system deviated from the predictions of gravitational models. The crucial piece of evidence was the timing. The flare event and the trajectory shift were synchronized. The moment of the energy release was the moment the course correction began. This cause and effect relationship made coincidence seem unlikely. The flare had produced a measurable thrust, acting like an engine to alter the object's path. This maneuver presented a profound question for the natural comet hypothesis. A comet's outgassing can produce a small amount of thrust, but it is typically weak, chaotic, and sustained over a long period. The event observed from 3I Atlas appeared to be the opposite, a single, powerful, and brief burst of energy that resulted in a clean and immediate course correction. It's consistent with the operation of a propulsion system. The ability to maneuver introduced the possibility of controlled action. The object appeared not just to be passing through on a path determined by chance, but to be following a path that it could actively adjust. This observation became the culminating anomaly of 3I Atlas, casting previous strange properties in a new light. These compounding anomalies led to two competing hypotheses. The first holds that 3I Atlas was a natural yet improbable interstellar comet. Its coplanar trajectory could be a statistical fluke. Its strange chemistry could be the fingerprint of its origin. The rhythmic signals could be a periodic internal process, and the maneuver the result of a powerful, unseen, outgassing event. This hypothesis preserves known principles of astrophysics. But at the cost of accepting that 3I Atlas was a strange object, the second hypothesis suggests that 3I Atlas was an object of technological origin. In this view, its improbable trajectory was not a coincidence, but a non-random outcome. Its metallic composition was evidence of engineering. Its rhythmic emissions were the functioning of an internal system, and its maneuver was the firing of a propulsion system. This explanation provides a unified framework for the observations. But at the cost of requiring the existence of technologies operating on interstellar scales, the final verdict on 3I Atlas is that there is no final verdict. It remains a profound scientific enigma, a collection of improbable characteristics and behaviors that defy easy classification. The object has since moved beyond the range of powerful telescopes, leaving behind a wealth of data that continues to be analyzed. Its transit served as a reminder that the universe can still present profound mysteries that challenge the understanding of what is possible.